So this topic is linear functions. So how can we determine if the function is linear or non-linear? How do we determine if a function is linear or non-linear? There's three ways. First is a linear function in two variables x and y. A linear function in two variables can be written in the form y equal to mx plus b, where m and b are constants. The second one, the second way we know that is that the graph of a linear function is going to be a line. So there are three ways we can find out if the function is linear or not. Okay, so the first one is written in y equal to mx plus b. Second is the graph is a non-vertical line. And the third is that linear function has a constant rate of change. So the rate at which it's changing is constant. So the first example here is, does the graph represent a linear function or non-linear function? So the first one you see is a U-shaped graph. So if it's a U-shaped graph, it's not a linear function. It's a non-linear function because it's not a line. If it's a line as part B, it's a linear function. Second one you see is a table, and you see x and y, 3, 36, 6, 30, 9, 24, and then 12, 18. So you see that the change is 3, and the change on the y it's reducing by 6. So x is changing by 3, or x is increasing by 3, and then y is decreasing by 6. So because it's changing constantly, the change is constant, so it's a linear function. So constant change means it's going to be a linear function. So if you see another example here, so if you see x is 1, 3, 5, and 7, so the change here is plus 2, right? So that is fine. But on the y, you see that it's kind of inconsistent. So 7, you have 11, and then you have 15. So that's not the same. So that kind of function, when it's not the same, is called, so the rate of change is not the same. So that's going to be called a nonlinear function. So its rate of change is not constant, so it's not a linear function. So now the second example is asking you whether these functions or the equations that they give you, are they linear or not? So the first one, it can be written in the form y equal to mx plus b, so that's a linear function, right? The second one, it's a square root, which is not y equal to mx plus b, can't write in that form, so that's not a linear function. The third, again, we can't write it as y equal to mx plus b. And then you see that you can't write in that form. So A is a linear function, which is fine. B, C, and D are not linear functions. So graphing linear functions. So the solution of a linear function is always going to be a value which is going to be an ordered pair, which has a x value, which has a y value. So it's an ordered pair. And there's something that's called discrete domain. So a discrete domain is a set of input values that consist of only certain numbers in an interval. So not the entire interval, but only certain numbers. On the other hand, if you have continuous domain, that's like a whole interval. So for example, if I have these numbers 0, 1, 2, 3, 4, and I see that those values are chosen as x, 0, 1, 2, 3, so that's called 0, 1, so 0 to 3 are making a discrete domain. All right. On the other hand, if you have continuous domain, so that one is going to be set of input values now in this case is continuous interval, all the values in the interval. So if you have points here, 0, 1, 2, 3, so the entire everything in that interval is included. So that's called continuous domain. Okay, so discrete is just fixed numbers, but continuous is all the numbers. So you're given a function. That function represents the cost y in US dollars of X tickets for a museum. So each customer can buy a maximum of 4 tickets So that's the restriction here. So the questions are: find the domain So find the domain of the function, and then is the domain discrete? So they're asking us, is the domain discrete or is it continuous? And explain it. Why are you saying what you're saying? And then graph the function. So how are we going to do this? So now we have to think a little bit that we have to buy tickets. We cannot buy partial tickets. It has to be 1 ticket, 2 tickets, 3 tickets, 4 tickets. You can't have 1.5 tickets because it's not like it's complete tickets. So if X is a whole number, so the maximum number of tickets is 4, right? So the domain is X equal to 0, 1, 2, 3, 4. So either you buy 0 tickets or 1 ticket or 2 tickets or 3 or 4. So it's discrete, right? It's not continuous. Right? So you can plug in these values and then you plug it in the equation for x, and then based on whatever that is, you find the value for y. So 15.95 times x, 15.95 times 1, 15.95 times 2, and then 15.95 times 4. And then we plot those points. So we have 0, 0, 1, comma 15.95, and then graph them. So we just have to figure out which these points, 0, 0, 0, and then you have 1, 15.95, then you have 2, 31.9, and you have 3, 47.85, and the last one is 4, 63.8. Okay, and then you plot them. All right? Perfect.